First, let's look at the shift cipher. It's a very simple symmetric cipher. In other words, the same key is used to encrypt the data as is used to decrypt the data. This is sometimes called the Caesar cipher. The key for this cipher is the number of spaces that we're going to shift each letter in our alphabet. So let's look at an example. We have this message, please encrypt this message, and we have our alphabet here. Let's use a shift key of 5. That means that we're going to shift our characters 5 spaces to the right. And notice how the last letters in the alphabet wrap around to the beginning. Now when we're ready to encrypt our message, first we'll encrypt the P. We'll look up P and see that it becomes a U. We'll then look up L and it becomes a Q. E and it becomes a J. A and it becomes an F. S becomes an X, and the last E will become a J also. So the first word of our encrypted message is UQJFXJ. Now we continue this for each of the subsequent words in our message, and now we have our encrypted message. This is a very simple cipher to decrypt because we just reverse the process to decrypt the message. Instead of looking up our letters on the bottom row, we now look up our letters on the top row. And we know how many spaces to shift it over because we've already shared our shift key with our partner who sent us this encrypted message. This is a very easy cipher to crack because there's only 26 possible combinations or different ways you could do it. And you could just try each of them until you had a message that popped out of your decryption algorithm. Something that's a little bit more complicated is a bit level symmetric cipher. Now in the shift cipher we worked it at the character level. The XOR cipher will work at the bit level. XOR is a logical function. It means exclusive OR. Let's look at a couple of truth tables here where 0 represents false and 1 represents true. A logical AND means that both A and B must be true for A and B to be true. And if you look at this table and look at the column for A and look at the column for B, you see the only time that the third column, A and B, has a 1 is when both A has a 1, which is true, B has a 1, which is true, then A and B, the result of that group is true also. The logical OR function means that either A or B must be true for A or B to be true. And in this table, if you look, anytime there's a 1 in column A or a 1 in column B, there's a 1 in column A or B. The only time A or B is false is when both A and B are false. An exclusive OR, the XOR, is true only if A or B is true, but not both of them. In other words, it's only true if A and B are not equal. So if A and B are both 0, A XOR B is false. And if A and B are both 1, A XOR B is false. Otherwise, if A is false and B is true, 0 and 1, A XOR B is true, or 1. And if A is true and B is false, A XOR B will be true, or 1 also. Well, let's look how we would use that in our cipher. Here's our message that we want to encrypt. Now we're going to translate each of these characters into their ASCII codes and use as our XOR key the characters CS, and we'll translate that into its ASCII code also. So here we have the ASCII code for P and the ASCII code for L. We're only going to encrypt the first 2 letters here just to give you an idea of how this works. Then we'll use our XOR key CS and put the ASCII code for CS here. Next, we do an exclusive OR between each of the bits in our message with each of the bits in our key. And the first bit of our encrypted message will be 0 XOR 0, which is 0. And then as you see here, we take each pair, XOR the 2 bits together, and in red you'll see what the bit of the encrypted message is. And then we look up and we use this XOR table in order to determine, okay, if A, which is our message that we want to encrypt, is 0, and our XOR key, which is B, is a 1, then we would have A XOR B, our encrypted message, would also be a 1. Now, this message will appear garbled if you don't actually have the key. With the previous message, with the shift cipher, you would still see a string of characters. But here, you're going to see just a bunch of garbage in a text editor if you go to look at this file. Well, we'll examine an encrypted file a little bit later. Now, in order to decrypt in an XOR cipher message, it's just the same process. We don't even have to reverse it because an exclusive OR will flip the bits that need to be flipped for us. We take our encrypted message and we do an exclusive OR with our key, and out pops the message. These are the two letters, P and L. Better encryption techniques will combine methods, and that's what we have with AES, or the Advanced Encryption Standard.